we're going to continue this section. This is my least favorite section to talk about, just because the idea of a binomial random variable is like the hardest thing to like grasp, because we don't talk about binomial random variables in real life, right? So what I did is we started with like the lamest game in all of history, where, oh, do we need one? Do you like passing this back? Go. Is that it?
We need two.
We need two? All right, here we go. Okay. So in our lamest game ever, I gave everyone a die and we rolled it 7 times. And we said getting a 3 was bad, right? So if we didn't get a 3, then we passed. And I rolled it and I passed 5 times, so X was 5. X describes the number of times that you succeed, okay? I said this was binomial because it passed 4 properties. The first property was that we have a fixed number of trials. The word fixed just means that it stays constant and it doesn't change, right? So no matter what happened in my experiment, I had to roll the die 7 times. There was no changing that, right? Number 2 was that I had this idea of succeeding and failing, right? There's no like other possibility, either success or failure. Number 3, the probability of success is the same on each trial. So rolling not a 3 on trial 1 has the same probability as rolling not a 3 on trial 5. It's always 5 out of 6, right? Finally, we have this idea of independence. So basically, trial 2 doesn't affect trial 3. So if I roll a 3 on trial 2, that doesn't affect what I roll in the next trial, okay? So we do have to pass these 4 properties. Some notation, N in just this section doesn't mean the number of things, it just means the number of trials, okay? And P is the probability that we succeed. So in our example, it was 5 out of 6. If P is the probability that we succeed, the probability of the opposite, failing, would be 1 minus P, right? Okay. So we did a couple examples where I gave you a situation and we had to find out if it was binomial or if it wasn't. And that basically was asking us, okay, are we following our 4 properties or not, right? Let's take a look at number 3, okay? In this example, we have 10 cards. They're in this box, okay? Half the cards are red and the other half of the cards are green, okay? What I'm gonna do is I'm gonna take 3 of the cards out of the box and I'm gonna draw them at random, okay? And I kind of wanna adjust this question because I wanna make it really obvious as to what's going on. I'm not gonna put the cards back after I take them out. So I'm gonna take out 1 card, I'm not gonna put it back. I'm gonna take out another card and I'm not gonna put it back. And then I'm gonna take out a 3rd card and I'm not gonna put it back, okay? So don't return the cards. Okay. Another way to say that is like we don't replace it, right? Let's go through this and see if we have a binomial random variable. Part 1, I need to figure out how many trials I have. I'm drawing 3 cards out of the box. How many trials do you think I have? 3, right? Because I'm taking a card out 3 times. So we definitely have 3 trials. At any point in this experiment, am I not going to take out 3 cards? Or am I always going to take out 3 cards no matter what happens? I'm always going to take out 3 cards, right? No matter what happens, 3 cards are coming out of that box. So we have a fixed number of trials. It's set to 3. We're past number 1. Number 2, we have to have an idea of success and failure. X always describes what the success is. So if X is drawing a red card, then success would be drawing a red card, right? So succeed is red. What do you think failure would be?
Not red.
Not red, perfect. All right, so it looks like we have a clear idea of succeeding and failing in this example. Number 2 is passed. I'm actually going to skip number 3 real quick and let's just go to number 4, okay? Number 4 talks about this idea of independence. Does one trial affect the other? And this is where it's really important that I wrote that we don't return the cards, okay? What I'm going to do here is let me just write out some of our trials. Let's do trial 1, trial 2, and trial 3, okay? If in my box, half the cards are red and half the cards are green, what's the probability of succeeding the first trial? Michael?
50.
50, right? 50% getting a red card because it's 50-50 red and green. Okay, so in trial 1, I have 5 out of 10 or 1/2 as my probability for taking out a red card. Okay. Let's say in trial 1, I actually do pull out a red card. Okay, so now I have a red card, but I'm not going to put it back. So now my box has 9 cards. Okay. What do you think my probability of getting a red card in trial 2 is? Well, I have 9 cards in my box. How many are red now? Oh, yes.
Should be 4.
4. I saw you raise your hand. I was like, ooh. Yes, 4, right? There's 4 red cards because I took out a red card. I didn't put it back. Now there's 4 cards. So now the probability of taking out a red card is 4 out of 9, which is different than a half, okay? This is an example where we don't have independent events because whatever happens in trial 1 affects what happens in trial 2, right? So this is not independent. Okay. If we don't have independence, do you think property 3, where all the probabilities have to be the same, is that satisfied either? No, right? Property 3, actually, if we fail property 4, we kind of automatically fail property 3, right? Unless like we have like a really crazy situation. But yeah, so property number 4 is not satisfied. You don't really have to check property 3 because we don't have a binomial experiment. This is not binomial. Okay. Let's take a look at number 4. We have a bag. Inside this bag, we have red, green, and blue balls. We have, we're going to take 10 balls out of the bag at random, one at a time. But every time I take out a ball this time, I'm going to replace it immediately, okay? So I take out a ball, figure out if it's great, like maybe it's green, put it back, take out another ball, oh, it's red, put it back, and then keep doing that 10 times. Let's see if this is binomial. Let's check number 1. How many trials do I have? 10, right? Because I'm taking 10 balls out of the bag. So 10 trials. Now, do you think that's ever going to change in my experiment? No, right? I'm taking out 10 balls no matter what. So no matter what happens, I have 10 trials.
The world ends still taking out that 10th ball.
Yes, that okay, maybe like at the 4th trial, like if the world does end, then I guess that does affect. I never thought of that, but yes, that can happen. What do you think the idea of success would be? Green, right? Because X represents the success. And here's where it gets a little tricky, okay? I do have 3 things that can happen, which makes it seem like, okay, maybe there's not really an idea of success or failure. What do you think failing would be? Not green, right? One thing that confuses people with the binomial distribution is, I mean, in this situation, we have 3 things that can happen. We can get red, green, or blue, but that doesn't really matter, right? The only thing that matters is if we have green or if we don't have green. Like in our other example, we either got 3 or not 3. It didn't matter if we had not, or if we rolled a 6 or rolled a 1, we still passed, right? So it doesn't really matter if we have like 3 options or 5 options. We have this idea of success and failure. Green, not green. So we do pass number 2. Part 3. Okay. If I replace the balls immediately after I take them out, do you think the probability of getting a green ball is going to be the same every time? Yeah, right. I'm replacing it. I'm restoring it to its original situation, right? So I put it back. Now the probability of getting that green ball is the same every time. So it looks like the probability stays the same for each trial. So I have a check mark here. Okay. Number 4, do I have this idea of independence? Does one trial affect the other? No, right? I'm replacing the ball each time. So if I get a green ball on trial 1, that's not going to affect the probability of getting a green ball in the second trial, right? So it looks like we have independence. Okay. So do I have a binomial experiment? Yes, right? Okay, this is binomial. Let's do one more. This time we have a coin, okay? I'm going to toss this coin until a head appears, and X is the number of, it's not the number of tosses, it's the number of heads that you get. Okay. All right. Well, how many trials do I have?
Undetermined.
Undetermined, right? we don't have a set number of trials, right? I could be really lucky and flip the coin once and get heads, and I would have one trial, right? Or I could be really unlucky and have to flip the coin 5 times until I get heads, right? So the number of trials actually depends on what happens. So do we pass number 1? No, right? We don't have a fixed number of trials. We don't know how many trials we have. It depends on the situation, okay? We don't cross number 1, so I guess this is not a binomial random variable. Okay. Any questions on determining if something's binomial or not binomial? I will say, like, I think this gets a little bit debatable. I think a lot of these can be kind of contested. I will say, like, on a test or quiz, I'm going to make it very obvious if it's binomial or not. I don't try to trick you too much with these, so hopefully it shouldn't be too bad. All right. Now, you're probably wondering, how do I find probabilities with binomial random variables, right? This is a probability section. And there's actually a couple ways we can find binomial probabilities. I will say the way that we used to teach it in this class is there was this huge formula that we were given. We had to memorize the formula, and then we had to plug stuff into the formula. And the formula wasn't just like a regular formula. It had like weird mathematical symbols, like the factorial symbol. It had like all this stuff multiplied together. And I'm going to say that, well, it's really hard to use that. Okay. So I'm not going to teach that in my class. I think other classes do teach it. If you want to learn how to do it just with paper and pencil, you can talk to me in my office hours. But I think it's way easier to use Minitab to find binomial probabilities. And you'll see how easy it is when I show you this. Okay. So let me just go through these steps here. First, you're going to figure out what n, the number of trials is, and p, the probability of success is. Step 2, you're going to go on C1, the column, the first column, and you're going to enter the numbers 0 through n. So if we have 8 trials, you're going to write 0 through 8 under C1. Okay. Step 3, you're going to click a bunch of stuff on Minitab. Okay. And what you're going to get is you're going to get a table or a probability distribution of all the things that are possible and the probabilities of each of those things. Okay. It's a very easy process, but I will tell you that I'm not going to give you the directions on the test. Okay. So especially step 3, I think you should at least write it on your note card when you take the test. Okay. This is a good note card thing. Okay. Because I will expect you to do that on the exam for this class. Okay. All right. Now, if this makes no sense to you, let's just do an actual example. I'll show you what to click, and you'll see how easy it is to come up with these probabilities instead of like doing them pencil and paper. All right. Let's go to example number 1. We have a research center. They recently reported that approximately 30% of anyone who uses the internet use Pinterest. Okay, they call it the image sharing website, which is very interesting. We have a simple random sample of 8 internet users. We take them and we want to use the binomial probability distribution to calculate these probabilities. Now, we kind of already told that this is binomial, so we don't really need to check the properties, right? I mean, you can go through the 4 properties, figure out if it's binomial or not, but we're being told it's binomial, okay? What do you think success would mean here? Yeah. They use Pinterest, right? So I'm going to someone, hey, do you use Pinterest? Yep, that's success, right? Uses Pinterest. How many trials do you think I have? 8, right? Because I'm going up to a person, asking them if they use Pinterest, and I do that 8 times, okay? And the probability, I guess, is 30%, right? Now, I will say that in this class, and especially when you use Minitab, we don't like percentages, okay? If you go on Minitab and you type in 30 as P, Minitab will freak out on you and it will tell you that you did the wrong thing, okay? What we use instead is we use decimals, okay? And what's 30% as a decimal? 0.3, okay? So if you're ever going on Minitab and it freaks out on you, might want to check to see if you typed in a percent instead of a decimal on Minitab. 0.3 is the way to go. All right. Now what I'm going to do is I'm going to show you what to click exactly on Minitab by sharing my screen here. All right, let's go here. All right, so I have Minitab up and running, hopefully. There we go. And let's just follow the steps on the back page here. So step 1 says, I need to figure out what N and P are. I already did that on my sheet, right? Step 2, enter the numbers 0 through N under column C1. So I'm going to go ahead and do that. I'm going to start by writing 0 on row 1, X out of that. 1, 2, 3. Where should I stop? 8. Yep. Just going to type, not 85, type in 8. That would be interesting. 0 through 8 on here. Okay. Then what I'm going to do is I'm going to click all the stuff that Minitab tells me to click. So I'm going to click on calc. I'm going to click on probability distributions. Okay. Yep. And then I'm going to click on probability density function. What probability density function tells you, it's literally that formula I was talking about with all that crazy stuff on it. That's a probability density function. This is basically telling Minitab to plug in those X values into that crazy function that I was telling you about that I'm not going to teach you. So we're going to click this. All right, Minitab needs a couple of things in order to find this, okay? Starting on form of input, instead of a single value is just telling you, okay, like what's the probability that X is 5 and what's the probability that X is 0? We actually want to type in the column of values because we want to calculate it for all the X values instead of just one. So we're going to do that. In the values in row, this is just Minitab asking, okay, what column are we inputting? So since I typed stuff into C1, I'm going to double click C1. Next, under distribution, there's actually a lot of different distributions. We've only really talked about the normal distribution and the binomial distribution so far. There's actually a lot. Here are all of them, okay? We won't learn about all of these in this class, but I guess we're talking about the binomial distribution, so we have to click that one. Okay, what do you think the number of trials is? 8. What do you think the event probability should be? 0.3. Remember, if you type in 30 here, Minitab will freak out because it has to be between 0 and 1. And then on the output thing, you really can choose either one of these, but I like the table because it just looks nicer. I'm going to click OK. And what I get here is I get a list of all the things that can happen, 0 through 8. And then I have all the probabilities listed next to them. I promise you, this is so much easier than plugging in these values to that formula because you'd have to do it for all the values 0 through 8, and you would not like yourself after you do that. Okay. Any questions on Minitab? All right. It's pretty easy. You just have to know what to click. So what I would do is on your note card, just like write the commands that you have to click on, and then you'll be good for the test. Okay. All right. Let me get my screen shared again. 3, 2, 1. Here we go. All right, so what I have up here is I have what I typed in the C1, I have everything I clicked on Minitab, and then on the right here, I have what Minitab spit out for me, okay? And it basically reads as a probability distribution, just like what you're gonna do on your quiz, right? So all those probability questions is basically how you answer these guys. Okay, so can someone tell me the probability that exactly 4 people use Pinterest? Yeah.
0.136137.
Perfect, 0.136. Ooh, that's a nice number. I like that. 136, 137. All right. Can someone tell me the strategy you'd use to find 3 or fewer?
0, 1, and 3. Subtract them from
Yeah, perfect.
1.
Or 0, 1, and 2, right? Is what you'd find. So 0, 1, and 2, I know those probabilities. 3 or fewer. Oh,
It is 3 or
it is 3. Sorry. I was like, no, that's wrong. Then okay. No, we are including 3 here. So we're gonna just take those probabilities and add them together, right? So let's go ahead and do that. I'm lazy. I'm gonna do like 4 decimal places. So we have 0.576, 0.19765. We have 0.2965. We have 0.8059 on my notes at least. Yes. That's pretty good. I can't do that in my head. All right. Last one, we want to find the probability of the people whose Pinterest is not to. Remember, not, that means to use the complement rule. What am I going to do with the probability of 2? 1 minus, subtract from 1. So 1 minus the probability of 2 is 0.2965. If I subtract that from 1, we get 0.7035. And that would be my answer for part C. All right. Any questions on these guys? So honestly, I think the Minitab method is way easier. I know Minitab is like not, a lot of people don't like Minitab, but I do think for this, it is a lot easier than doing it by hand. Okay.
The question is it free software? I don't think it is. So
Yeah,
using,
I think you can use Excel too,
Excel, okay.
but that's not free either.
Well, then you can use Google Sheets for it. Excel has it.
Yeah, I bet there's like free stuff on the internet you can use too. Yeah. All right. Let's do example number 2. Okay, I'm gonna set this one up with you, and then I'll give you some time to work on this. Here, we have a basketball player. He has a 60% chance of making each free throw. This is different than that other example we did where we had different basketball players because, well, with the different ones, each of them had a different probability of making the shot. This time we just have one person, and assuming he doesn't get tired halfway through, he has the same probability of making the shot every time. Okay. Okay, what do you think success means here? Making the shot, making the free throw, right? So making the shot. How many trials do I have? 6. What's the event probability? 60% or 0.6, right? Now, does anyone want me to show you how to type this in a Minitab, or do you think we're good? I think we're good, right? I mean, it's basically the same thing, except this time I'm writing 0 through 6 on that first column instead of 0 through 8. This is what Minitab spits out at you. Why don't we spend the next, I don't know, 3-ish minutes going through A through C? I'm sorry I'm blasting through this, but I want to have enough time to go through the quiz. Okay, I do know that some of you are working, but I do want to get through the set of notes today so that we can start the normal distribution on Monday. So let's just kind of go through this. If you're still working, don't really worry about it. We'll go over these together. What did we get for part A? What was the probability for exactly 3? Just give me the first 2 decimal points. 0.276480. I don't think anyone wants to read out that full decimal. So that was just by reading the chart, right? What would the strategy be for part B? Greater than 2, not including 2. Perfect, right? Just add up everything, not including 2, but greater than 2. I'm not going to write that up. Did we all get 0.8208? Yes. Okay, that makes me feel good. Sometimes when I do it in my office, I like miscalculate it, and then I'm like, oh, darn it, I have to do it in class. Okay. And what would the strategy be for part C be?
1 minus 0.311.
Yep, 1 minus 0.31104, right? And we get 0.68896 as my final answer. All right. Any questions on parts A through C? All right, then we're going to talk about the very last part of the notes. This is kind of the easy part, okay? And I'll kind of explain why, okay? Whenever we have a probability distribution, like for example, on the quiz, I'm going to ask you to find the mean and the standard deviation, right? Now, if we take a look at what just popped out on Minitab, does anyone want to find the mean and standard deviation of this guy? Like, what if I put this on the quiz? Yeah, that would be a really mean of me to put that on the quiz, right? Like, if you were to find the mean, you have to multiply across, add together. With the standard deviation, you'd have to make that chart and then multiply it by the probabilities. And that would not be fun, right? So there's actually a trick with binomial random variables only. Okay, don't do this for the quiz because the quiz is a binomial, okay? But if we have a binomial random variable, we actually have a little shortcut to find the mean and standard deviation of the chart, okay? The mean formula is just taking n, the number of trials, and multiplying it by the probability of success, p. So n times p is literally the mean. You can go and try it yourself on the last example, just multiply across and add down. You'll get the same thing as n times p, okay? This is a formula that you do have to memorize, or at least write on your note card, okay? I will ask you that on the test, okay? But it's really simple. You multiply n times p, okay? If I ever ask you the variance, you also have to know this formula. But even though it looks more complicated, it really isn't, okay? It's n times p times 1 minus p. What did we say 1 minus p was the probability of? Timothy? It not happening, right? So p is the probability of success. 1 minus p is the probability of the opposite of success, which is failing, right? So it's really not that hard to memorize. It's the number of things times the probability of succeeding times 1 minus that probability, which is the opposite, okay? Now the standard deviation formula looks a little bit crazy, but does anyone see how simple it is? Yeah, why is it simple? Yeah, it's just the square root of the variance, right? We know that to go from the variance to the standard deviation, you just take the square root of the variance formula, right? So it literally is this variance formula that is up here in the middle, and you just put a square root over it, okay? So you don't need to memorize that formula oh my God, in of itself. You just need to know that to go from variance to standard deviation, you take the square root, which we already know that because we've done that a bunch of times, right? Okay. Let's do a small example. We have the probability that a new car of some sort of model will require repairs during the warranty period is 0.15. Okay. Do you think 0.15 is N or P? P, right? So P is the probability of success. Isn't that kind of weird that success here is the probability that it will require repairs? I guess, yeah, if you think about it in a different perspective, I guess that is good, right? Now, does succeeding have to be a good thing? No, not in this case, right? I mean, in real life, yes, it is good for the dealership. I never really thought of that, honestly. But yeah, succeeding doesn't really need to be good for anyone, right? Succeeding just has to be the thing that you're interested in, right? Okay. The dealership sells 80 cars. What letter does 80 represent? There's only one more. N, right? So N is 80. Okay. And I want to find, I know that X is binomial, even though it didn't give it to me. We could go through those properties and see if it is binomial, but it is. I'll just tell you that. I want to find the mean and standard deviation of X. Okay, let's find the mean first. Remember, the mean formula is N times P. So all we really have to do is multiply 80 times 0.15. I actually already did that in my calculator. I got this to be 12. Let's find the variance. The variance is N times P times 1 minus P. Okay, so it's a little bit harder this time because we got to plug in one more thing, but it's 80 times 0.15 times 1 minus 0.15. Okay, I like doing the subtraction first and writing it down because if I don't write it down, I will get this wrong, I promise. 1 minus 0.15 is 0.85. Then in my calculator, I'll go and multiply those three numbers to get 10.2 as my variance. Now, that's not the standard deviation, right? What should I do to get the standard deviation this time? Take the square root, right? Just like you're going to do on your quiz. The square root of 10.2, oh my God, it's not 2. It's 3.19.